No,
has he though?
so when they
You
launch
fell
Artemis,
off,
you guys
dude.
just
It's all
say no,
good.
huh?
You
So
fell
when they
off.
launch Artemis,
I'm
you
just
just
kind
say
of
no,
curious,
huh?
like when you say any more and fell off, like that has a pretty heavy implication.
I don't care. Just trying to
Yeah,
get
I'm
to me.
I'm kind of wondering the same thing. When
They're trying
did
to get,
I?
they're
Because
trying to get in
since
my
I've
head.
been here, I haven't noticed anything positive
Of
from
course
him,
not. Of
other than
course not.
devolving the room into bickering.
Of course
Hey
not.
NASA, can I ask you a question?
On the
Can I
fact
ask you a
that
straight? Can I ask you a
oh please,
straightforward question?
what
Will you answer if straightforward?
depends. Tell me.
Uh, okay. If the interference pattern, like the fringe shift, right? The interferometry fringe shift that's
Surface what?
measured at the surface and say like an MMX style demonstration, if it increases proportionate to altitude, would that refute the claim that that like it is detecting no motion of ether?
Do you have the data for this, or you just proposed an experiment?
Yes, I do. Let me ask you another straightforward question. If I were to take a gyroscope and it the fringe shift that was in that ring laser gyroscope increased with altitude, would that refute the claim that the cause was Earth rotation?
Uh, you mean Nodell's gyroscope? You
So, like,
understand
yeah,
you understand they
like a ring.
analyzed that. You understand they analyzed that, and it was within the error expected of the
Wait, who
instrument.
who wait, who what? No, I'm not
Back when
talking about
Nodell
any.
released, back when Bob Nodell, back when
No.
Jeremy here embarrassed Bob
Bob's
Nodell
measurements were
into
no good. Bob's
no,
measurements
they're
were no
excellent,
good.
actually quite good. No, and
No.
Jeremy actually embarrassed him into releasing the
They're
raw
quite
data,
good, huh?
and
Bob's
they were
measurements, they put the sensitivity up
not
way too high.
yeah. What
So
they did was, but the Octards analyzed it within I think within a day and found that it was all within the error of the instrument.
Yeah,
okay,
you know, it's
that isn't what I was
what's
asking you
I know,
about
but what's
though.
your first one was found to be temperature differences. That's what generally the scientific
No, it
community.
wasn't found
Hold
to
on.
be
Let me just
temperature differences.
let me just finish. I'm almost done.
Hey,
So yeah,
brother, I would love to
most of the
hear your
things that the
answer
scientists
if
do.
if
Hold
you
on.
answer my
Let me just.
question.
I just wanted to say one thing, and you just can't stop your help.
It just
That's
sucks
how it's done.
because you just answered my
No,
question and then
I
say your
want
thing. You know what I
because
mean?
you had two things you said. I want to make sure I keep it straight. So the first one was about high altitude studies, and I think the consensus for most scientists is that it's temperature related. The second one you said, I don't quite understand what you said there. You said on the gyroscopes, like the ring laser gyroscopes, you're saying they have some type of proportionate change in their readings at altitudes. Is that what you said? I just want to make sure I didn't miss it.
I wasn't even making a claim, right? Like I'm just asking a question. And
I
my
know. What is your
question was if the fringe shift in a ring laser gyroscope were to increase with altitude, like proportionate to altitude, would that refute the claim that the cause of the fringe shift was Earth rotation?
Well, we'd have to learn more about what that fringe shift was and how much it did change, and then what other variables could affect the fringe shift in a ring laser gyroscope, which is quite different than the Michelson-Morley experiment. Even
Yeah,
though
it's in a vacuum sealed chamber, bro.
right.
Yeah.
Materials still are temperature related. I don't
Oh
know.
my god.
I would say
Oh my
that
god.
if you could rule out all the other factors, yes, it could refute that
Thank
particular
you. Okay.
device.
Because of
But
course, if it was Earth rotation, that rate would stay the same independent of altitude. It's only relative to latitudes, right?
Why would altitude change something in a vacuum sealed
That's what I'm saying, right? Yeah, why
temperature? Would
would it? Right. Okay.
the
So, and then
do you have data? Do you have the data for this or not?
no, he's
wait,
just asking.
I'm
Oh,
just
you don't
asking.
have the data for this.
Well, this is the point, right? Like, you guys are afraid of even interacting with hypotheticals. Like, to be fair, Zanick did, right? But here is the other point. If we go back to the MMX, right? And you said that it was proven to be because of temperatures, which isn't true, but
The general
also it's
consensus was
MMX. Wait a minute. Michelson-Morley experiment. That was
yeah,
140 years ago. What's it? That was
no one cares.
that was
No one
no
cares.
one cares. It was
So
140
what?
No.
years
Chill.
ago.
What?
And
The hell?
So they've
specifically,
redone
specifically,
the experiment. they have redone the experiment over and over again, and they've gotten
Okay,
much
do you want me to
more.
drop one of the
They've gotten
papers that
much
you're
more.
talking about?
They have gotten much more accurate results, so that the
Mhm.
time difference between the
He's
two
talking about
legs is now.
Miller's. He's talking about
So
Miller's
the
experiments
Okay, can I
time
respond?
difference. So the time
100
difference
years
between
ago.
the time difference between the two legs is now 10 to the minus 19th, which
Okay,
is
I'm
a
gonna
lot
respond.
better.
Okay,
Which is a lot better
so
than Michelson Morley.
the issue that you have is you are assumptively conflating a result nearer to zero with more accurate due to your bias and presupposition that that is the accurate result. And therefore, who cares what needs to be done in order to achieve that desired result? As long as I see the numbers closer to zero, that means it must be more accurate because I know that that's the proper result. Okay, that's
No, but
No, well, that
insanely
is the result.
fallacious.
That is the result. I don't care if you
No,
think it's the proper
well,
result.
when you
it
change the
said
arm, when
The
you change the
result.
length of arms, and you go put them in basements, and you go put them and run them through crystals, and you do whatever you can to change the propagation rate of one of the beams because you keep getting an interference pattern, that is not science. That is not a true measurement. That is you fulfilling a bias, and that's what most of those tests did. That's why I
Oh,
asked if you want to drop
Jesus.
a paper. If you want to drop a paper where they don't cook the books by actually running it through a crystal or extending the length of one of the arms and trying to make it closer to zero by slowing, quote unquote, one of the light beams, because, let's just use common sense. If both of the light beams are supposed to be the same and there should be zero fringe shift, if I have to consistently slow one of the light beams by introducing a crystal bit so that it gets closer to zero, what does that tell us? That tells us
Yeah,
that
that
one of the
Tells
light
me
beams is
it tells
actually
me you don't
faster than
understand.
the other one.
It tells me you don't understand the experiment. That's
no, it's
Yeah.
just like
Yeah,
Foucault
yeah.
pendulum. Just
No,
like the
it's not.
Foucault pendulum. They do it
Not.
until they get it right.
Well,
the
that's
focal
that.
pendulum is. They do it until they get it right? Because if
Yeah,
you
they
introduce
do. They
bias,
make adjustments until they get the
you know
expected
you know
result, and that's what
you
Witsit
know
talking about with
if
MMS.
if you put in a bias into the telescope, into the focal pendulum, it'll stay there, right? So you have to make
Hey,
sure you
but
don't put any bias into it when you release it. That's the problem with the focal pendulum.
before
What?
it gets
What?
fully lost, can we talk about this whole like temperature claim? Okay, like Zanick, are you aware that MMS was you know this? It was replicated, right, by Elias. I think that's how he says it.
Right.
And okay, and so he said, "Please give me any explanation as to what this could be." And he went and tested all of them, right? And so
Mhm.
temperature was the leading proposed explanation. So he took like radiant heat sources and introduced it directly to the device, like in close proximity to the interferometer. And it did not affect the results proportionate to the consistently measured fringe shift. So he completely nullified that as an answer. And this is the follow-up piece of data that's extremely interesting, right? Um and you know this too, I think. It showed a correlation with time of year, right?
Right.
So like if we just think about it in like really, really simple terms, it's like, okay, before they proposed the theory of relativity and everyone kind of accepted the ether and we assume the earth is rotating and revolving around the sun, logically speaking, right, based on how we know that the motion of a medium will cause the light beam to, go faster, right? C plus V. We took that understanding, which is well known and established and proven, and we applied it to the assumption of an ether and the assumption that we're orbiting the earth. So therefore, based on which way we're orbiting and which way the light beams are going,
Orbiting
the
the sun,
light
you mean.
beams are going to go different speeds. The
Orbiting the
light beams
sun.
are going to go different. Yeah, orbiting the sun. So
Okay.
so we're going to
So
go different. That's what MMX was about. It was about the orbit, right?
remember, you should also be talking about Michelson Gill Pierce. I mean, just so we
Well,
know.
no, we're not there. We're not there
I
yet.
know,
Like,
but that was something that actually got definitive answers for this friendship based on the rotational, the
which is
accelerated.
exactly what would be expected if the Earth weren't moving and then the universe was rotating around it. Because if there was no orbit but there was a rotation, then that
Mhm.
nullifies the Earth moving as the explanation. But instead of accepting that on its face, we of course had to come up with some way to hook the books, do some mental gymnastics to explain why you just can't detect the orbit one. But I promise it's still there. But like back to my point, bro. Like it is interesting, right? Like if the idea is that we're moving around, real fast, if the idea is we're moving around real fast, and if the idea is we're moving around the sun, and that's what gives us seasons, right? Supposedly we move one time around the sun every year, and we get 4
Seasons are due
seasons
to the
because of that.
tilt. The seasons are
Yeah.
due to the tilt, not the
The se-
movement.
wait, come
And
on.
you're not going real fast, and we could go back and forth. So you gish gallop, and you kind of like throw a bunch of things out. You scattergun, and it's tough to really address. And that's why I speak so quickly when I'm talking to you, because you
Okay.
always you're hyperactive like I am, but you got to be able to
But
pare back.
but
a
I'm
little
just
bit.
trying to lay the
You
foreground
already
for
laid
this.
it out. I get it. Stop. You had me.
No, there's like 2 more sentences.
I know, but you had the first point was actually well taken by you.
But this
And
is
now
but this
I almost forgot what it is because you keep on going.
because
Alright,
this is
and
that's not the point I want to make.
Just let him finish, bro.
Right. So if they believe we're moving around the sun, you guys believe that, right? And we do that once a year. It is pretty interesting that the test we design, right, based on the orbit, actually did give us like a measurement that directly correlated to time of year. That's my point, right? Like the azimuths. So you have the equinoxes, right? Like the fact that the measurements corresponded to the equinoxes, and it was the highest in one equinox and the lowest in the other equinox, it was changing throughout the year based on solar motion.
Okay, you made the point. You belabored the point, but I wanted to go back to
What is your response to that? What's your take on that?
This is why I don't want you to keep on going because I'm fixated on answering the first objection, and you bring 5 other points to the table. I don't remember.
You got to respond to all of it. So I hope you took notes.
I
That's the problem.
to the last one.
Brandolini's law here.
I don't mind.
When you spout out 5 or 6 lies there, and it takes 10 minutes to undo each lie,
Everything
we're
I
talking an
said
hour
was
here.
with what your side agrees with. That's why I don't understand the interruption.
Because first of all, if it's a flat Earth and it's rotating, and you're saying with stationary rotating, and the atmosphere or the ether is rotating around it, and we have this 15 degree per hour measurement, that means the ether should be moving much faster through these sensors and these tests, these light tests at the outer wall of Antarctica versus the North Pole. We don't see that. Number 2, when we have jet airlines, which have 3-ring laser gyroscopes, which gives you the 3 axis of rotations, and we see what's happening, that they actually won't even be allowed to take off unless we do measure that 15 degree per hour change with the 3-ring laser. That's anywhere, whether you be in North America or the equator or South America. So that doesn't really follow this ether, right? I mean, I know it's not exactly.
We're not even talking about 15 degrees per hour at all. It isn't even relevant at all.
It seems like it was. Okay.
This is why I went through the painfully rudimentary foundation of the sun. The earth moves around the sun in 1 year, seasons, earth, around the sun, orbit, around the sun. I don't get, like, why do we immediately talk about the daily sidereal rotation, right? Which is what 15 degrees is. So, like, I'm talking about the sun. The idea the earth moves around the sun. We did we didn't detect the orbital motion that we assumed happens around the sun. So, of course, we propose, Lorentz contraction, and then ultimately the implied necessity of time dilation within relativity, blah, 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 blah. As to say, well, we won't detect it. It did change, but only in the reference frame of the sun. We can't detect it in the earth. Whatever, very convenient, magic. Okay. But just in really simple terms, right? Like, Earth moves around the sun. Try to test and measure Earth move around the sun. That test measurement showed a direct correlation based on solar motion, where the sun was throughout the year. This is a major problem if we're going to claim tests can't detect around the sun.
You have 2 sets of errors, right? You have the first errors that were within the error margin, which were the initial values. And you're saying now that they also detected errors seasonally as well as altitudinally, if that's a word. Right? There's 3 sets of errors that you're talking about. Is that really how you're framing this?
No. That's how you're framing it, right? Like, it wasn't within the error margin. It wasn't within the error margin. But even if I were to just pretend for a second that it wasn't, but if we pretend for a second that it was, okay, why is it directly correlating to solar motions?
I don't believe it was directly correlated to solar motions at all. In fact, like I said, it was in the error margin because if it was traveling around the sun at 66,000 miles an hour, we would have saw this particular diffraction pattern that we didn't see. They didn't detect. Now you're saying they saw the error did change in different altitudes, and it did change for different seasons. They saw they're very, but still within the error margin. But why was it in a certain? I wanted to research that to find out if it was in a certain the same direction that would parallel the motion. If it was somewhat, even though it wasn't the amount that they were looking for, or what we thought was the velocity or the speed around the sun, that we get something that actually follows that same direction. And I don't know whether they did that or not. I thought it was a plus or minus error.
It's always the same direction. So,
It could be. Yeah.
which is inconvenient for the claim that it's an error, right? Because an error would have no directional preference,
Well, it could
right?
be a non-zero and non-negative type of error based on the apparatus and the type of structure and mechanism that you're dealing with. That's not uncommon at all. But I mean, I'll give you that. I don't know. I don't know for sure what the errors were, and I know they were well within the error of margin based on what they were looking for, what they thought the speeds were going to be. So
No,
that was that. But
no.
yeah, general consensus was for the apparatus that there was a temperature, maybe a thermal issue that could have been present going up at altitude versus on the surface. And the three-wing laser gyros, I think, will play through a whole different set of rules versus MMX.
Okay, so I was typing something. If it was an error margin, what like let's pretend it's hypothetical so we can just actually get some substance, right? Because the actuality of it really just throws you guys off. So it's hypothetical. If there is a consistently detected and measured correlation between the fringe shift that is measured and the solar motion, the time of year, specifically the equinoxes, but it changed all throughout the year, as in like day after day after day after day, the amount measured slightly changed. And it reached its highest at one equinox and its lowest at the other equinox. And it did this year after year after year, right? With hundreds of thousands of measurements. So do you agree if that were the case, hypothetically, that like the claim of an error doesn't work? Like instrumental error isn't a sufficient explanation.
What I don't no, I don't agree with that at all. I think let me throw out something random. It could be a gravitational effect of the apparatus.
Well, for one, that wouldn't be an instrumental error, right?
Right, it could be a gravitational effect.
Okay,
Close to
so
the
it
sun.
wouldn't be an instrumental error, though.
Yeah, it could be, yeah, it's absolutely possible. It could be just something else. Don't say it has to be ether, because that does seem to be disproven by the tests they did do, and the incredibly exhaustive amounts of tests they did using MMX as
Well,
well as
let's not get carried away, bro. Like,
but I'm just saying it could be something else, and they should probably test for
yeah,
that.
yeah, but we agree what it can't be is instrumental error.
No, because you could have gravitational effects on the instrument would cause instrumental error.
So the gravitational effects change day to day to day throughout the year relative to solar motion.
Yes,
Do they?
yes, absolutely.
Can you drop a paper that shows that gravity changes in a singular direction relative to solar motion? Because then you'd be able to see a slight variation in that effect based on latitude. The issue, and I think you're actually smart enough to know this, and that's why you would invoke something like gravity, is like you conveniently can always claim like 30 other variables, right? Like, oh, the density of the mountain, oh, the composition of the materials inside the mountain, oh, it was
Why are you
cloudy. It's like
making fun? Why are you making fun of it?
because
Those
it's like a
those
BS
are variables.
excuse that you can never boil down, right? Like
Well,
if
yeah, you can
that's
actually.
that's not valuable in science. No, you can't because if you say that claim, which I've never heard in my life, that gravity changes at a
Yeah,
single location based
I
on
don't think it
solar
does.
motion.
You don't think it does?
I don't believe in your version of gravity, so I wouldn't be
Well,
particularly surprised if
I'm
there's
just
some
talking
type
about
of
the
electromagnetic
I'll
variance.
post something. There, that's a simple search gives you this. Gravitational force between the Earth and Earth changes slightly throughout the year because the Earth's orbit is elliptical, not perfectly circular, with the distance varying about 4%. The Earth closer to the Sun in perihelion in January results in stronger gravity, and the farthest perihelion is in July, resulting in weaker gravity. So yeah, we all know this. You know this too, I'm sure.
Okay. Okay.
That would be now. You say, then I say, oh, I don't believe in gravity.
Okay.
Well,
So it's based on orbital motion.
hold on. All I'm talking about is dropping something. We don't know what causes it. We don't care if it's bending over space-time. We know there's
Oh
something
no.
that causes things to drop. That's what I'm saying. That
I think you know you just messed
hold on,
up,
God, let me
bro.
just finish.
Yeah.
I'd let you finish everything. Just let me finish the
Oh,
sentence.
there you go. You just messed
Slow
up.
down and make it more listenable. So what I'm saying is that just the fact that we observe this thing called quote gravity, that could be affecting these tests. I don't go into what causes it.
Okay.
That could change it. Okay, thank you.
Okay. So based on what you just read, can you tell me what you think the problem would be in the context of our conversation?
Well, it would bend the path of light slightly.
No.
So
Based
light
on
is
what you just read, could you tell me what would be the problem with that explanation in the context of our conversation?
well, in the context of the conversation, you have an instrument. An instrument has measurements of straightness, of mirrors, of light's paths, the type of light
Okay,
it is.
bro. Let me re-ask the question.
When
The
Can
results
you
would
pretend
change.
to be
when it is in
me?
presence and when it's in the presence of gravity, it doesn't follow a straight path. It follows a geodesic path, which may
Okay,
look
I
curved,
know.
but actually is
I'm
straight.
not.
I know you know this. So I don't know why you're objecting to my objection.
Bro, why? No, we haven't gotten there yet. Can you pretend to be on my side of the conversation? And if you were, and then you were to now reread your sentence out loud, which is that there is a slight variance based on, or there's slight variance of gravity based on the time of year due to the orbital motion because it's an elliptical path. So if you were me, if you're on this side of the conversation, which we know what my argument is, right? Instrumental error is not a sufficient explanation. Okay.
Because you're
So
going faster.
if
Going
well,
faster.
I'm just curious, like if you were me, can you spot the problem?
I'm guessing it maybe has to do with the velocity. You're thinking that because we were going faster at the
No.
no? Okay.
No,
Velocity.
okay. So the problem is that you said gravity, right? Sounds cool or whatever, but turns out you end up saying it's because of our motion, right? Our orbital motion. That's the exact thing that your mainstream paradigm claims isn't being detected.
As far as what?
So
As far as measurements on Earth, the gravitational change.
no. MMX, the claim is that we are not detecting the effects of orbital motion with our interferometer.
Yeah, the Earth is in free fall. No forces are acting on it around that trajectory.
Okay, so can we turn around and then have our cake and eat it too, and then claim that the direct correlation with the periodicity of the solar motion and the interferometer somehow is because of orbital motion?
Now we're getting to the relativistic aspects of that statement. So yes, it's almost like the satellites. Are they following? Yes. But what is really happening? What's really happening is we're matching the centrifugal force with the centripetal force. Is
Oh
that
man.
really what's happening? I mean, how do we measure forces on the ISS? Is gravity still? They do transforms to say if we weren't moving, we'd fall straight down, and this is the acceleration we'd apparently take before we hit the Earth. So I mean, we're getting in a whole bunch of loaded statement questions. It's not as simple. You make it seem like it's so straight, cut and dry, and it's not. You're laughing now too.
Well, I mean, I'm laughing because I've been away for a while, but I
I
still
know you have. It's
remember.
good to hear you
I
back.
still
Trust
remember.
me, I like
I
to hear
still
your voice.
remember,
I like
bro. I still
I like your
remember that.
creativity.
That's your go-to. That's
I
your
like your
go-to when you're
I
in the
like your
corner. You
creativity, and I
just
like
start
your
relativity babbling, dude.
not relative. Dude, these are things that are
That-
part of
that-
Einsteinian
That's
physics.
not
I mean,
relevant to what we're
you've
talking
read
about.
enough about it. I know you haven't studied it, but you've read enough of it to know as much as anybody who's been graduated in physics that has not been in school in 10 years. You could probably have a great debate with them.
All right,
So
man. Thanks for the
I like the
backhanded.
spirit. I
But
like the
hey,
spirit.
man.
Hey,
Hey, man.
I'm gonna give you a bone.
So,
Just you can't even let
a
people talk and give them a
backhanded
bone
compliment. So look, dude,
because
this is the
it's
thing.
not a
This is
backhanded
the thing.
He's
compliment.
It was
interrupting. Does
it
he ever
was
not
backhanded.
interrupt?
It was
It's not a
backhanded.
backhanded comment. You just babbling on. You won't stop talking.
No, that's not true. You were babbling on.
No,
It's
I
all
wasn't.
good, but
I
it's
was
just
being
funny.
very
But look,
specific about my objection.
no, bruh. Everything you
Mhm.
just said is entirely irrelevant. It was obfuscation, and you know that. And that's because you really don't have an answer. You realize that, yeah, you're right. I just contradicted myself, right? Like you can't claim